Multithreading is the process of executing multiple threads simultaneously to perform tasks concurrently. Multithreading allows a program to perform multiple tasks at the same time by running multiple threads in parallel. So think of a thread as a lightweight process. By using multiple threads, you can make your applications faster, more responsive, and more effective. In Java, a thread is the smallest unit of execution. Multithreading is part of Java's java.lang package. So when a Java program starts up, one thread begins running immediately. This is usually called the main thread of your program because it is the one that is executed when our program begins. So there are certain properties associated with a main thread which are represented here. So it is the thread from which other child threads will be spawned. Often it must be the last thread to finish execution because it performs various shutdown action. So why we use multi-threading? In real world, multi-threading powers everything from games and web servers to Android apps and banking systems. So it helps in concurrency by running multiple tasks at the same time. Example like music playing while downloading, and performance wise like utilizing multiple CPU cores for a better performance and keeps application responsive and faster execution. So here is the difference between threads and process. Memory wise, thread shares memory, but process separates memory. And thread communication is faster, and process is a bit slower. And thread creation is lightweight, and process creation is heavyweight. How to create threads in Java? So there are a couple of ways. One is to extending thread class. Another is to implementing runnable interface. The step is you just create a class. Here example like I have created a class called my thread and extending thread class, and we have to override run method and just have some statements like here I'm using just a print statement. You can have any logic within that method. And the next thing is create a thread class, like create the object for the class which you have created and start it. The only four steps like just create a class and extend thread for it and override a run method, then create a object for the class which you have created using extending thread, then start it. The same approach for implementing runnable interface as well. Here in this case, instead of extending, you are implementing runnable interface and using the same run method. And one extra step is you need to create a thread object and pass the whatever the method whatever the class you have created to it. So just pass class which you have created using implementing runnable to the thread object, then start it. Here is the thread lifecycle. So we have a certain lifecycle for thread creation and execution. The first will be a new phase, that is thread object is created using a thread class but not started yet. It's not yet eligible to run. That is just creating a thread object. Here example like I'm just creating an object and assigning the class to it, or creating the class itself which using extending thread. So it's a first phase, that is a new phase. Then a runnable phase, that is a thread becomes eligible to run after calling dot start method. So it's waiting for CPU to assign time. That's it's called like runnable. Then running is like the thread scheduler picks a thread from a runnable pool to run. Then Java doesn't have a explicit running state, but a runnable thread may actually be running. Then we have a blocked and waiting stage. That is, thread is trying to enter a synchronized block or method, but the lock is held by another thread. So we can have a synchronized block as well to overcome a race condition and also using synchronized keyword. So here the thread will be in the blocked stage or waiting for the completion of one thread and all. So then we have a waiting as well. That is, a thread waits indefinitely until another thread notifies it. There is no timeout and all. So here we can use two option, that is wait and join. So wait you can use inside synchronized block, and join is like a join method is like waiting for another thread to finish. Then we have a timed out or timed waiting phase, that is a thread waits for a specific time and then becomes runnable again. So you can use a sleep method to halt your program for a provided time period. That is for a certain number of hours, minutes, seconds, and all. You can halt your program's execution. You can achieve it through using again sleep method, join method, and wait method. And terminated or dead phase, that is thread finishes its execution or is stopped due to an exception. That is after executing that run method and all. And here is the phases like a new, runnable, running, block, and terminated. So basically, implementing runnable is better because Java supports multiple interfaces, but only single inheritance. That is like, let's say if you have implemented a runnable interface, you can extend other class as well with implementing other interfaces. So the thread methods, which we already seen that we have a start method to start the thread, then run like which contains logics within the thread class, and then sleep to halt the thread temporarily, then join, so waits for another thread to finish, and is alive to check if thread is running or not. Then set priority. You can set the priority for a thread as well. Then we have a concept called thread synchronization. So, what if a multiple thread access the same data? So you could get unexpected result, which causes race condition. So to prevent this, Java provides synchronization. So thread synchronization is a mechanism to control the access of multiple thread to shared resources. So when two or more threads try to access a shared resource simultaneously, there can be a inconsistent behavior or data corruption. So to prevent this, we use synchronization to make sure only one thread can access the critical section at a time. So we can use synchronized keyword here. You can see the whole method is synchronized. So uh, there won't be a race conditions and all. So without a synchronization, thread may overwrite each other changes. So use synchronized methods or blocks to ensure that only one thread accesses the critical section at a time. Like in the banking system or in the e-commerce and all, we use synchronization. So in detail examples we'll see in the later part of this video or in the next video. So inter-thread communication, which allows threads to communicate and coordinate with each other, like as I mentioned, like wait, notify, and notify all. Like let's say within the synchronized block or method, you have called a wait method, which will wait your thread, and notify will wakes up the threading or the thread. Then thread scheduling. Thread scheduler decide which thread runs next, and it's based on the priority and availability of CPU. So Java uses thread slicing strategies, and you can utilize those things as well. So then comes the thread pools. So creating too many threads is expensive. So Java provides thread pools to manage multiple threads effectively and efficiently. So here again we have classes called executor services, and there are certain available classes and interface under this as well. We'll see those things also. So here the concept is, instead of calling all the threads, so just make a pool of it, like uh, execute one after the other. Let's say you have created a pool with a 5, so and you have a 10 threads, so the first 5 will be called, then after that the next rest of the threads will be called. That's how we achieve thread pooling and all. So the real world examples, like file downloading app, like one thread download the file, then another thread show download progress, the third one will be save logs and all. The same goes for billing system, like for one for scanning item, then the other thread is for update inventory, the third one is for print receipt. The same thing, like you can have a multiple thread as well. And Android app, like main thread is your UI updates, and background threads like fetching data and all using async task, handler thread or executors. So here are some of the multi-threading issues, like race condition, like threads modifying the shared data wrongly, then deadlock, that is like threads waiting on each other's forever, and starvation, like low priority thread never runs, then thread leakage is for like threads not being released. So here are the best practices, like use thread safe data structure when needed, and prefer executor services over manually creating the thread. Then use synchronize, volatile, or lock to control your thread access. Then use thread sleep with caution, like better use wait or notify when needed. We'll see a simple example for multi-threading. Here is a simple example, that is I have created a class for ordering the food. It's just an high level one, and I have a constructor just to initialize the customer name. Then as soon as I call the thread, as soon as I start the thread, what happens is, like customer name, it prints the customer name saying placed an order with a thread number, whatever the thread number that system assigns. Then sleep means I have called a sleep method here just to sleep or halt the execution of the thread for certain period of time. And it's just to show you that, like simulating the time taken to cook and pack and all is just a representation here. Then once that is done, like once the sleep is completed, then order ready for the customer. And here you see I have used extending like thread class. Then I have used all the means I have created object like order 1 2 3 4, and I have provided the name. So the first restaurant is open, then create some object for the class, then start it, like whatever the object you have created, start those things. So let me execute it. Here you can see restaurant is open, all orders are being processed concurrently. Then you can see 1302 means the thread 2 started first, then 130, and order ready for all four objects. Let me execute it again. Now you can see the thread 0 1 2 3 got started, like all four started sequentially. If I execute again, the behavior is the same, but you can see that that's how thread works. Like you never know which one will be started first and will be completed, but your system will take care of assigning the things. So this is all about multi-threading in Java. Again, the synchronization, pooling and all will be done in next videos. Thanks for watching.